Today's lesson is looking at graphs from a table, and with this idea of graphs from a table, it'd be really easy with this problem right here, if this is your function f of x, to be able to find exactly what function value we're approaching as we approach 3 from the left and from the right. It's really clear that this answer should be 4, but what if I wasn't given that graph? How would I know? Well, we can use a table of values to be able to help us do just that. So in this table of values, remember we want the limit as x approaches 3. So notice I'm getting really close to 3, 2.9, 2.99, 2.999. Same on this side, getting closer to 3 from the positive side. So as I get closer to 3 for my x value, what does it look like my y value is getting really close to on both sides? And the answer again is you're getting really close to 4, really close to 4. So your answer, yes, is 4. Now this value right here, well, if this hole was filled in, yeah, it would be 4, and that's cool. It's not always going to be that way, though. It's very possible as you're doing table of values, what if this hole was not filled there, but filled right here? This could be a value of 1. But again, they don't want to know what the function value is. They want to know what we're approaching. So it looks like, hey, I'm approaching 4. Oh, it's all of a sudden 1. And hey, now it's all of a sudden looks like it's getting really close to 4 again. So make sure you keep that in mind as you're going through these problems and filling in tables of values, or even getting tables of values when you work on Delta Math. So let's look at another problem. And this time they don't give you the function value. So we can find the function values, though, by just plugging each of these in. The issue is that's not exactly the easiest thing to do, going 3.999, squaring it, subtracting 16, and then dividing it by 0.001 on the bottom. So what we can do, though, is if you pull out your calculator, let's take a look at this, and gives us a good chance to practice doing the calculator part as well. So the numerator was x squared minus 16, make sure that's all in parentheses, divided by x minus 4 in your denominator. And you hit graph, or I will hit zoom 6 to make sure I'm in the proper zoom there. And we wanted to know the limit as x approached 4. So what I'm going to do is I'm going to go with the trace. It's not the most accurate, but it'll work fine for what we're doing here. And honestly, all we're going to do is we're going to hit trace for each value. So I'm going to type in 3.9, hit enter, and it gives me a function value of 7.9. So I'll go back and write in a function value of 7.9. I'll do the same with 3.99, and it happens I get 7.99. And this ends up being 7.999. It doesn't always work that way, it just kind of does here. And these should be, check yourself here, 8.001, 8.01, 8.1. If I go with 4 here in the middle, if I type in trace 4, I don't get a y value. Well, why would that make sense? Well, if I plug in 4, I'm dividing by 0. I can't do that. So there's an instance where your value there does not exist. But we can figure out, though, what my limit is. What am I approaching? I'm approaching a y value of 8 as I get really close. Here's problem number 3, and the last problem we're going to do. What I want you to do is first see if you can figure out what the x values are that we should do if we're doing a limit as x approaches 1. Then type it into your calculator and get the y values as well. So I'm going to suggest pausing the video, trying the x values. Hit play, you'll check your x's. Pause again to try to find the function values. Hit play again, and we'll look at what those values are and what your limit answer is. Alright, so first, to find what your value should be, we're approaching 1, so I want to try to get close to 1 on both sides. Get really close. Bigger is pretty easy, 1.001, 1.01, 1.1. From this side, you would want 0.9, 0.99, then closest would be 0.999. So there's what your x values are. Go ahead and pause again if you needed that to check, and then we'll have the function values here in a second. All right, you're just going to go one at a time. When you plug in 0.9, it gets 2.7. 0.99 gives you 2.97. So just notice how it's a little different from this last problem. 0.999 is 2.997. Interesting pattern. If you type in 1, it shouldn't work, which makes sense. You can't plug in 1, so nothing there. When you plug in the other values, though, we get 3.003. When you go 0.01, it's 3.03. And this guy is 3.3. So as you're approaching 1 from the left and the right, the function value, the y value you're approaching from the left and the right appears to be 3. And there's all you need to know about tables. I will say one more thing, just for an example. If this had said, let's look at number 2. If these were this number and then maybe this was 10.001 and 10.01 and 10.1. Am I approaching the same value from the left and the right? It looks like I'm approaching 8, I'm approaching 10. That would be an example of the limit not existing. So take a look at that too when you're going through your problems on Delta Math.